All right, we're hearing a lot about wearable computers, particularly ones on the face. We've seen the Google Glass. We've been to Meta to see the space glasses and a variety of other glasses. But the problem is, how do you make this thing cheaper and smaller and more battery efficient? And Infinity Augmented Reality has an answer to that, and we're going to hear about it right now. Who are you?
Hi, my name is Modi Kushner. I'm the CEO of Infinity AR. I started this startup 2 years ago. Prior to that, I was the Chief Marketing Officer of Telmap. We sold the company to Intel about 2 years ago. And what I'm doing is I'm trying to help my boy play more realistic video games. That's what I'm doing here.
Well, that's a good way to be cool dad.
Yeah, I was playing, the whole startup started 2 years ago. We were playing chess. Okay, and then his classmate, entered the house and said, "Would you like to play Wii?" The boy looked at me, looked at his friend, dropped me and went to play Wii. And I was staring at him and thinking to myself, 30 years ago, I got my first Atari, and I was playing with my friend, staring at the screen, detached from the environment. What's wrong here? Can we do something new? And that was the idea. How can we allow those two boys interact like we did, right, on a board game, but with the excitement of a video game?
Yeah. Now, you're building the engine or the glasses or both?
Okay, so we are building the engine. Okay. We will require some hardware, of course, but unlike all the other solutions that you have today in the market that require huge battery and can last for, I don't know, maybe 15 minutes, we're requiring only 2D stereoscopic cameras. And with that, we can build the 3D environment around you. We know where you are at all time. We allow you to control virtual objects, but more than that, we are the engine that kind of translates the physical world into your virtual world. So if you are an Infinity developer, a Unity developer, you will need Infinity in order to build or to extract the data from the physical world.
Yeah. So you need a pair of glasses that has 2 video cameras, just standard video cameras, right?
Just simple VGA, one color, one black and white. They can build all of this magic.
So the people who are angry at Google for putting a camera on Google Glass with privacy, they're really going to love you because you have 2 cameras, right?
I think Google took it one step too fast, okay, right? If you look at what we really, when you have new products like that, you don't put it immediately on the street and allow people to do face recognition, right? Let's start with some fun. Let's have 2 boys sitting at home and playing Monopoly or chess or even new interactions you cannot imagine. We have a demo in our office that you can play Angry Birds, okay, that we built, but from the point of view of the bird.
Yeah.
Think about it. You are now feeling as if you are flying towards the islands, or it's amazing new experience that you can get.
So I'm still a little confused. Are you going to build glasses, or do you work with an existing company?
We are working with an existing company. Our demo is running currently on Vuzix because they are the one to first provide stereoscopic cameras, but we are now talking to different providers of glasses. When we told them about our ideas, they were immediately, start scratching their heads and said, how come we didn't thought about it, right? It sounds easy. It's not that easy to support all the computation and the right, smart algorithm behind it. But the truth, they much prefer to have additional camera on top of the glasses instead of, a 3D sensor.
Yeah, and a 3D sensor has the Meta space glasses that I saw have a front-facing 3D sensor, but it can only see about 15 feet away from you, right? The 3D sensor throws light, laser light or ultraviolet light, and measures the time it takes to get back and builds a 3D model. Your approach could go much further and can work in bright sunlight, I would assume.
Right, so you got few of the points, which means truly we can work outside because infrared light will not interfere. We can work one against each other, right? Face to face, because we are passive sensors, nothing will interfere. As for the distance, the truth is, as a human, you cannot tell the depth beyond 6 meters. I can replace what everything is behind 6 meters with a poster. You will never know. It's your brain playing with you. So the
Which
truth
is actually a trick that Hollywood uses all the
Exactly.
time. They paint things behind the actors,
Exactly.
and you can't tell because your eye can't see that.
The rule is that you can sense depth 100 times, double the length between your eyes. Okay, so if
100 times.
right, if this is 6 centimeters, you can sense depth up to 6 meters. Now, if you look at the depth sensor, they're trying to generate depth out of every pixel. I couldn't care less. That's what's smart about us. When you look at the table, yes, I want to give you depth for every pixel. When you look at the distance, I don't care. Right? You will not feel it as well. And that's how you can save computation and power, and that's how it should work.
When I went to Meta, they had a team of people developing software to build a new user interface, a new machine computer interface, or a new machine human interface, right? Because we don't have a mouse on the table like we used to have. Now we have our hands in the air, and we have sensors that can tell we're spinning our head and stuff like that. Are you building that new operating system that's going to let us do things with our hands?
Yeah, I think what we currently see in the market is trying to take gestures into the 3D environment. Okay, so you will see actions that will tell you to hold, grab, move, release. I don't do it with my physical things, right? If I want to grab a glass, I will just grab it and take it. So the next generation of gestures, we don't like to call it gesture, we call it hand control.
Hand control.
Right, so that's the way I control stuff. I don't need to teach my little boy how to grab a chess piece, right? I can just take it, grab it. So we are now working on a technology that allows your brain to understand that you catch this piece by lightning and have some signal of voice. But at the end, we need to recognize that you just capture a piece, right? And you want to grab it and move it or leave it. That's the idea.
But that's a lot of computer science, isn't it?
That's a lot of computer science. My CTO, he's a graduated of a project in Israel called Talpiot, which every year they select the 30 most talented guys, put them through university. So this guy did 3 degrees in parallel, math, physics, computer science. It wasn't enough for him, so he did his master and PhD in parallel to working in a military factories that design navigation for unmanned aircraft using computer vision. So
he's a smart guy.
Extremely smart. Extremely smart. So I had this idea, and I keep looking for those kind of guys. Okay, and I interviewed some of them. Okay, and most of them told me impossible. And then this guy, I liked his answer the most. He told me, "Give me a week." Okay, and he called me after a week. He said, "I already drafted the sketch, and how can I do that?" And ever since, you know how it is in startup, we're kind of a married guy.
How soon is it going to be before we can buy this and play with it at home?
I think there are a mixture of things that need to be mature. So you need the optics, right? You need the content, and you need our technology. So I think that at the beginning of next year, you will start to see companies working with different technologies to embed them in their glasses. So I guess something at the beginning of 2016, mid 2016, we will start to see those kind of solutions. It's a question whether it will be first for the enterprise industry or for consumer. I think enterprise will adopt it first.
Do you see other places where this technology might be useful, for instance, controlling a dashboard in a car?
Think about a surgeon, okay? Those guys are spending more than 25% of their time in the room looking at data instead of operating. So if you have a very complex operation to do, it might take 6-8 hours. Think about it, 45% of the time is looking through data to understand what to do. Think if the doctor can now have those glasses on top of him, and the entire information will lie over the patient, right? So you can now look at different slices of the MRI and so on. So I think it will go over there.
I've been visiting Tel Aviv all week, and we're here in the Mobley offices. Thank you, Mobley, for letting us do interviews here. What's going on here? Because there's more startups here who are doing this kind of hard science, R&D.
Why is it happening here?
Yeah, what's going on here? What's in the water here that makes you different than New York or Berlin or Los Angeles or Seattle, right?
I'll give you what I think happens here. Okay, you are joining the army. They put in front of you a task and tell you, listen, we don't need to replicate it. It must be on time. Think out of the box. No budgets, limitation. Just try to build it, okay? And you build it. You think out of the box. You get the solution right, and you move to the next project, right? So if you look at it, we don't have skills of building huge manufacturers, or because we are extremely focused on, having one project, unlimited budget. Let's do that. And also, it's something with the Israeli culture. If you think something, I know how to do it better.
Yeah. What's your business challenge now for the next 2 years to build this?
I think the biggest challenge will be to hire the right personnel. You can't build this kind of startup unless you have the sharpest minds. So I think that's one point. And the other point is to convince the industry that that's the right solution. Take it forward.
So you're probably raising funding. Have you raised any funding for this company?
We raised $2.5 million in April from Singularity, which hosts us here, an additional fund in the US, and it will help us to develop the proof of concept of the technology, and hopefully we'll mature it.
Very cool. Well, thank you for giving me a little taste of what's going on here in Tel Aviv. Where do we learn more about it?
You can visit our website at infinityar.com. Everything in there, our Facebook page.
Very cool. Well, thank you so much.
Thanks, it was a pleasure.
So a few weeks ago, Apple bought this little Israeli company called PrimeSense, and a lot of people are like, well, what does PrimeSense make? Well, they make 3D sensors. We saw them at the Consumer Electronics Show last year. But we have a new company that's using their sensor on top of an iPad, and they're going to change the world. And the sensor is called a structure sensor. The company is called Occipital. We're going to see it right now. And who are you?
My name is Jeff Powers. I'm co-founder and CEO of Occipital. We started the company about 5 years ago, and before that I dropped out of school, a PhD program at the University of Michigan, to start a company. So straight to the company from me, no previous employers.
No, and you guys have built some remarkable products over the years. You did the red laser, right?
Yep.
That does scanning of stuff, and eBay bought that.
Yes.
And you did some 3D or 360 panoramic app.
Yeah.
So there's some smart people there. Something's going on.
We have a good team. We know we kind of pride ourselves in knowing kind of what's going to happen in the future of computer vision on mobile and trying to participate in it as much as we can.
Well, we should we should start out by talking about PrimeSense, because PrimeSense just got bought by Apple, and you use PrimeSense's sensor in your product, right?
Yeah.
Tell me about the world of 3D sensors and why we need a 3D sensor instead of just a regular camera like this GoPro,
Yeah. So, regular cameras like that are awesome, and they're getting much, much better. But what they can't do is they can't sense actual metric size and scale of objects. And so to achieve the magical, experiences that we see in the movies where computers can just see and 3D map things instantly, we feel that it's better to have a 3D sensor than to try to do it from 2D images alone in computer vision. So that's why we think it makes sense. And maybe in the future, maybe 10 years from now, the compute power will be so amazing and the cameras will be so good that we won't need these sensors anymore. But right now, we think it's just a huge no-brainer to add a 3D sensor for the apps that we're building.
For a computer guy like you, what does that sensor show you that a 2D sensor can't show you?
So it gives you metric distance to surfaces and objects. And so instead of sensing RGB colors, we now sense distance. So we know the color of something from the camera that's built into like the iPad, but then the sensor itself gives us the metric distance. So we can say, this point on that table is 18 inches away, and that other point is 21 inches away. And with all that information, we can reconstruct very accurately and very quickly a model of the world.
And so now let's talk about your sensor.
Yeah.
Can you show me it? And
Yep.
why do we need this on our iPad?
So this is our product here. Like you said, it's called the structure sensor. And until now, the only way to really get access to the kind of data that we just talked about, 3D sensing data and do reconstruction of objects, was using an external accessory that plugs into a computer. And so we saw a ton of opportunity to take that kind of tech and put it into a form factor and make it friendly to work with iOS devices. And that's really what the structure sensor does.
Now, this is not the latest PrimeSense sensor, because the guy who started PrimeSense showed me a new sensor that's a stick of chewing gum thick.
Yeah,
right?
so there's those guys are working on something new that's using a new type of projector technology. And as we understand, it's not ready for mass production. The last we heard was maybe sometime spring of next year, or of this coming year.
Yeah.
So we're actually using a slightly older projector technology. But when you look at our product, you can see that it's basically, it's approaching the form factor that you saw. And we have new things inside. We have a battery inside. And the reason that we're getting close to the same size is because instead of having a plastic shell, we're using an anodized aluminum case to serve as both the exterior and as structural interior of the device.
Interesting. And so how much does this cost, first of all?
So the overall device, including the attachment mechanism that hooks it up to the iPad and the cable and everything, is $350 on Kickstarter. We actually just ended a Kickstarter campaign.
Yeah.
We haven't announced what our future pricing will be, but we're taking pre-orders right now for $350.
Okay. And who is going to use this? Is this going to be a real estate agent who needs to map out a building inside? Tell me what kinds of use cases you think people are going to use it for.
There's all kinds of cool stuff. You mentioned real estate. There's definitely a lot of people contacting us. A lot of our backers are developers. In fact, many of them are interested in real estate applications. Some are interested in crime scene mapping and reconstruction. Some are interested in 3D scanning of objects and people. Kind of a new trend, maybe a fad, but it's taking off right now. Scanning people, scanning objects, 3D printing them. A lot of people want to be able to do that and not be constrained by cords and plugging into large computers. The idea of being able to scan mobile makes sense. And so a lot of people are going to be using it for that. And one other area that a smaller number of companies are working on, but we think is really exciting, is augmented reality gaming. The ability to map a space and then turn it into a game world that's very accurate. So you can have very interesting interactions where, in fact, the virtual objects can duck and hide underneath real objects, and that starts to get really interesting.
And I think that's why Apple bought PrimeSense, right? The company that makes your sensor that you're including in here, because I'm sure they're going to put this on a TV product of some kind, and now they have the same features possible that is in the Xbox One with the Kinect sensor, right?
Yeah, so the Xbox One is, of course, not using the same tech. Microsoft built something in-house that's a different technology, but achieves the same kind of depth information. And yeah, we don't know exactly what Apple's going to do with the PrimeSense technology. We're interested to see. Our big hope is that we can continue to innovate with the structure sensor and build amazing 3D apps on the iOS platform until such future time that this tech becomes built in. I mean, at our core, we're a software company. That's what we're building. The things that we're most excited about are our computer vision algorithms and engines. We just needed this sensor to exist, and so we brought it into the world.
Well, the neat thing about the way you're building the sensor is you're putting it on an iPad, a mobile platform right away, where the Kinect is meant to sit on a TV or next to a TV and be watching a room. And yeah, that's great for that room, but hey, we're out in the world, going shopping. Here you can do something. Can you show me what it sees and give me some examples of things that you're playing with?
So let's start out with just a really simple demo here. I'll just literally show you what it sees. And so here you can see, I'm showing you this color, which is representing distance. You can see the table in front of us is red and yellow to indicate its distance.
And if I put my hand here?
Yeah, so now your hand is white, sort of indicate that it's at the minimum closest distance.
Okay.
And as you go further away, it gets different color.
Yeah.
I can also switch to another view here where we see the raw depth. So you can see someone sitting over there. It's 300 and some centimeters away. The wall is 400 centimeters away. The table is about 58, 40, 44, 39 centimeters away.
And my hand
and
here.
your hand is 35 centimeters away.
Okay.
So that's the raw data that comes from the sensor. So let's flip out of that app. Would you like to see another demo?
Yeah, keep going.
Cool.
That's cool.
So let's head into what we call scanner demo. And what we can do here is point at this camera that's sitting on the table. I got a very familiar multi-touch gesture here. I can just scale the size of this cube and so that it fits the camera on the table here.
Yeah.
And then you can see the cube's actually resting right on the table. I can press scan, and here we're capturing a model of this camera. I can move around at pretty normal rates. I don't need to go super slow. The system is tracking my motion the whole time.
Be careful, you're mic'd in.
I'm mic'd in, so I'll just stop here.
Okay.
And we'll go sit back down. But what we did just here is captured a model of this camera. Now this is using some very early prototype coloring code. So the color isn't that good, but if I pop on the mesh, you can see a pretty good quality, all things considered, simple model of this camera. And so you could share this with someone, you could send it to a 3D printer, you could even send it virtually to an online 3D printer. We have a button here that sends it to Shapeways, but you could send it to MakerBot Thingiverse, you could send it to all sorts of different services.
Oh, that is cool. And if you are more careful with it, it'll get sharper as you walk around?
It will enhance over time. I can also show you a black and white monochrome scan where we're just focusing on the mesh itself. And so here we're just getting all the geometry of the object.
Yep.
So we could continue, of course, if I could walk around and get the whole object. So that's another demo app.
Yep.
And we can pop into one more demo that makes sense here, I think, on the table. So this one's called Fetch. And whoop, I'm having some strange behaviors. Okay, what I'm going to do here is I'm actually going to scan this object again.
Okay.
But instead of what we did before, which was use it as an object we wanted to scan, instead what we're going to do is actually use it as an object in a virtual game. And so I now have this virtual cat that is going after this ball. Now, I didn't map the full table, so it's running right off the table, but you can see I drop this ball and it bounces right off of that object.
That is cool. So new kinds of games are possible, new kinds of entertainment, new kinds of kids' photos.
Exactly.
And even some, when I went to the Connect Sense Techstars startup incubator up in Seattle, they are doing scanning of bodies, and they figured out they could get within a 1/4 inch of your body, so they could put custom clothes on you and do all sorts of fun stuff, right?
That's another cool thing we didn't even really talk about earlier, which is the ability to use this in home to scan a human body and, like you said, recover a model. Use that model then to do clothes shopping without having to go to the store anymore. Because I hate clothes shopping. It's a huge time suck. If I could just see 100 different garments on my body all at once, that would radically change the way people shop, I think.
So you sold on Kickstarter, I think, $1 million worth of these things at 300 and something a pop, 350 a pop. Where do you think this is going? And is this going to be a $1 billion business someday, or is it just going to start being built into? And let me turn that off. Is it just going to be built into the products that we know and love?
I think the hardware eventually is. Like what we're doing, the $1 billion idea that I see we're going after is more of the software that powers this. Because no matter what sensors you have, you need an amazing software engine to put all that data together very rapidly. That involves amazing processing that's on the device. It involves cloud processing. It's a big challenge, just in the way today that computer game engines are these huge monolithic beasts that only a few companies can build. In the same way, I think vision engines will be the same way. And so I think the $1 billion thing we're going after is that. But that said, we intend and hope to have a long life building this awesome hardware accessory as well. And I'm excited to work on generation 2 and beyond, because I think there's a lot we can do for the next few years before this tech makes its way in. And frankly speaking, we may see 1 or 2 devices that have these sensors, but I personally believe there'll be small successes or even failures until we have the software to back up why do we need these sensors.
Yeah. these sensors are great for a room, like you were pointing it around.
Yeah.
It's not good for walking into a baseball stadium
True.
and seeing the whole baseball stadium yet, right?
Yep.
It can't see that far.
That's right. Yeah, they can't. They have a limited range, so they're really good indoors. They're good with objects the size of a person, smaller than a person, up to the size of a room. But yeah, if you take it into a stadium, it can't work. And it's basically based on the same principle that human eyes are based on. You have a certain parallax, a certain distance between your two eyes, and you can see objects that are roughly some relative fraction of this distance away. But if you look, into the great distance, you can't really predict exactly how many miles away something is. And in the same way, these sensors have the same type of problem. So even if you had a stereo system which could theoretically see really far, its accuracy at far ranges is not very good. So in that case, what we do is rely on a different technique where we track motion as the user walks around walks around the stadium, and we then recover the stadium's geometry over a long period of time, and images from people all over the world and things like that. And people are already working on this particular problem. It's not something we use every day, but the technique is
Well, I think, eventually if we come back in 10 years or something like that, we're going to walk into a baseball stadium, aim our camera at home plate, and it's going to tell us all sorts of stuff about what's on the field.
Certainly.
And it's sort of like our TV does today, right?
Yeah.
When you watched America's Cup, it showed you the whole course, right, for the America's Cup out in the Bay. Even though our eyes can't perceive where those markers are, right? But they could, with computers, put down the field and flow patterns and wind patterns and all sorts of stuff. And that makes your experience at a sporting event like that much more enjoyable, right?
Yeah, certainly. I mean, there's a lot of information like that contextually makes sense to present to people. But today we have no medium to present it because AR isn't good enough and tracking isn't good enough. But like you say, in 10 years, it's going to be there. And then the challenge is going to become building the apps and figuring out what information do you present and what do you not present? Because the answer isn't present everything, right? The answer is figuring out how to get away with just the right amount of information and understand what the user wants. And we're not even really facing that problem yet because we don't have the underlying tech to present stuff well enough. But I think in 10 years, we'll be facing that problem.
Yeah, it's going to be an interesting world to watch. I think that's why Apple bought in. I think that's why Microsoft bought in. Certainly, if you could make this smaller to fit on a phone and you're walking through a store and it's mapping out the world in real time.
Yeah, or Google Glass, right?
Well, Google Glass is a good example. It's still ways from getting a sensor, even a bubblegum sensor, on there.
Yeah.
And then the battery life and the computation power to deal with the data flows that are coming off that sensor are a little bit taxing at the moment, right?
For sure. We're pushing the limits of what you can do on these devices. I mean, our demos seem fast, 30 frames per second, but I can't tell you how hard it was for our team to pull that off. And it's going to be pushing the limits of devices for the next 5 years, I think. But it's going to be cool to watch because it's going to get more and more accurate.
I didn't even think about this, but you showed me a new iPad Air, which has a new 64-bit processor. Are you pushing that processor to its limits?
We can do more, but we already are using basically all the resources. So there's a lot more that we can do to push it even further. But I mean, we've done all the easy stuff, and so it's certainly a challenge to make that happen.
What else are you, because you're building a sensor company, I'm sure you're now getting all the sensor catalogs from every lab that's making sensors.
Yeah.
What else are you seeing happen in the world, and does this fit into a bigger context of things happening?
I think it does. I mean, there's a few other companies out there that are building sensors. There's nobody that's doing exactly what we're doing today. I'm sure that'll change. There's a company called Soft Kinetic. There's a company called PMD. They both make time-of-flight sensors, which are an interesting technology.
What is
time of flight? So they literally measure in some way the time that it takes light to travel and return from a surface. So
they're
amazing.
throwing a laser.
Yeah.
In fact, doesn't PrimeSense do a little bit of the laser pattern?
There's a laser-based projector technology, and sometimes they use lasers, sometimes they use LEDs. So a lot of the guys that are using time of flight, including the Kinect from Microsoft, are using LEDs, and so they're just blasting the scene with light and watching how fast it takes for that light to come back. It's kind of amazing to think that we can measure the time at the speed of light. It's not infinite. So there's that kind of technology out there, and there's other things in the space, but it'll be interesting to see how it evolves and as we get new players building sensors.
Yeah. What got you attracted to this? Because you've been working on this for 2 years now, before most people knew what a Kinect sensor was. So what got you into this world?
So a couple of years ago, we were playing with a Kinect, and we were also trying to build an augmented reality engine at the same time. And we saw what we were able to pull off ourselves. It was kind of like some of the stuff you see with the flat markers or a little bit of mapping, but it's not very accurate. And then we played with a Kinect, and it was really clunky and plugged into the wall, but we saw these amazing things that we could do. In fact, some of the prototype code that we played with was one of the Kinect accelerator companies, ManCTL. They made an app called ScanAct. We were playing with their app, and we saw how amazing it could be if we just had that on mobile. And we knew that it wasn't going to go anywhere if you still had to plug it into a big computer. So it had to be brought to mobile devices. We looked around and there was nothing out there. And so that's what led us down the path of moving from being a pure software company, which is what we had always done, to figuring out how to build hardware, growing our team, creating this device, and now launching it 2 years later.
Leap Motion, another sensor company, uses a sensor that's facing up from your keyboard to watch your hands and do a new kind of gesture-based human-machine interface, right?
Yeah.
Are you able to do the same thing by turning the sensor up and aiming it up, and then can I use my hands to do new kinds of gestures or new kinds of interfaces?
So those guys are doing cool stuff, not really the same as what we're doing. Conceivably, though, a developer with structure could take this cable, which is what we call our hacker cable. Instead of plugging into the iPad, it plugs into USB. And so you could imagine looking up at a person's hand and processing the raw feed coming from the camera and doing some of that same tracking. But intrinsically, the device wasn't built to do that, and so I can't say it would be as good as Leap Motion, but they're similar in terms of they're both infrared-based input devices.
Yeah. There's another company called YouMove that watches your face. Are you thinking of working with other companies that are pushing the technology in another way, not the way you are, but to join them together to make a new kind of game available or a new kind of interface?
I think what's so awesome about this kind of hardware renaissance that we're seeing now, smaller companies starting to build hardware again, I think what's interesting about it is we're all building these kind of crazy things that we're not even sure if there's a big enough market. They're not devices that on their first year are going to sell $1 billion worth of goods. But they'll sell millions, and that's enough for small startups, right? And so what's cool is we have all these different things. We have the Oculus Rift, we have the structure sensor, we have Leap Motion, we have the eye tracker that you mentioned. Yeah. What I think is really cool.
And a few others. I'm seeing Meta, which makes some
glasses. Meta glasses. Yeah. So what I think is awesome about that is that we can now kind of put all these things together that otherwise wouldn't have existed were it not for all these small companies. We can start to put them together and imagine, think one step further. So if I can put a head tracker on, use a structure sensor, have a Google Glass on, I don't know, I can start to imagine some future interface. And the user experience will be bad because these tools weren't built, with these future apps in mind. But what they'll do is they'll let us imagine the future apps. What if you could scan a room with an Oculus or with a structure sensor, display it in an Oculus Rift halfway around the world, basically in real time? Okay, what applications become possible then, right? So that's what I'm most excited about.
When I visited PrimeSense at CES, they had a company called Shop Perception there that was putting PrimeSense sensors over people's heads at like a Walmart, and we're able to watch shopping analytics, the movement of people in space. Are you thinking of doing that? Because you've given us an affordable way to do that. Like my brother's bar, he could buy an iPad and one of your sensors and go to town, right?
I hope people do stuff like that. We don't know exactly what are all the cool applications, right? Since we're not experts in all these fields, we don't know if having a mobile sensor is kind of a game changer or not. But what we did, just in case it is we made it super open and hackable. So these people can build companies' products around the sensor, and we made it very hackable. We have, like I said, a special cable that lets you plug it into pretty much anything. On the bottom of the sensor, there's standard screws that you can screw in and build your own attachment bracket. Even this thing I'm showing you here on the iPad Air is actually a prototype 3D printed bracket. We're printing this on Shapeways, and so this is print to order, sent to us via the web. You don't need to have any fabrication facilities. So someone could have an idea, print their own attachment that puts it on the wall, the ceiling, gets this cable, and then goes to town with a new solution.
It's pretty cool. How were you funded? Because you made some money off the sale of Red Laser, and you sold. Did you sell the 3D
360 is still ours. Yeah,
360
so
is still
we still
yours?
run that. Yeah, so we sold the Red Laser app and reinvested basically that money, and also raised a Series A from Foundry Group, and also a minority stake from K9 Ventures, Manu Kumar.
Yeah. Manu always gets his fingers in the coolest stuff. I've noticed that. Whatever that guy gets his fingers into is pretty cool, and usually he has he invested in Nitro and the coin that we just saw.
Yeah.
So he's getting his fingers in cool stuff.
Yeah.
Is there anything else we should know about this sensor and maybe its capabilities? Or first of all, it's coming out soon, right?
Yes. So
you're shipping by the end of the year.
Yes, we are. So the first thing you should know is that the Kickstarter campaign is over, but people can now pre-order sensors on our site, which is structure.io. So if anybody wants to get their hands on one of these early and develop something, grab one on structure.io, because we only have a limited quantity of those. We're basically building ahead to demand. So I recommend pre-ordering and not waiting. We're not going to charge people until, at least currently, we're not charging until ship, so it's a good time to get in. Other than that, some cool stuff for people to know is that the sensor is able to take advantage of the very high-res camera on the iPad, and it fuses the high-res iPad camera color image with the sensor data, which means, comparison to some of the existing sensors out there, you're going to have a much more gorgeous color image, and that's going to result in better scans, better mapping.
I didn't think about this, but can I put that on an iPhone?
You can, yeah. So you can plug it into an iPhone, although we don't officially support the iPhone because we're not making attachment brackets for the iPhone and not officially marketing it as being supporting the iPhone. But the Lightning connector is the same.
But some kid with a 3D printer is going to figure that out.
They're going to do that. We're going to encourage that. We want people to do whatever they want with this thing. So you can do that. You can attach it to those devices, and the iPhone 5S is very fast.
Yeah.
One other thing for people to know is that if somebody has a cool idea to use the sensor as part of a permanent installation, let's say you want to put it on the wall at your office and build a face scanner for people to get scanned in when they walk in and unlocks the door, for example, you can actually do that, and the sensor is capable of passing power through and charging the iPad. So you can have this plugged in on the wall, doing cool scans of people walking by or whatever you want. And that's kind of a cool feature that's we didn't really ever talk about, and we're excited for people to use that.
How long will the battery last on this,
So
if you're shooting with it full time?
So we did some cool stuff so that the sensor basically goes to sleep when it's not being used. So you can keep it plugged in, but if you're scanning full time, 100% power, the sensor will run for about 4 hours straight from the battery.
Okay.
Typically speaking, that means multiple days of use because you don't run it for 4 hours straight for most applications. You'll get tired walking around with the sensor for an hour.
Are you walking around and mapping neighborhoods by aiming your sensor all over the place?
We're trying to get mapping of our office working first, and then we'll map neighborhoods.
Very cool. Where do we get more information on?
So go to structure.io. We also have a cool video on our Kickstarter, so you can search Structure Kickstarter and get a pretty nice video demonstration of it working. There's cool articles all around. TechCrunch had a cool in-person interview to check out, which really shows the structure sensor in action. And actually, this video is one of the cool new places to see our prototype brackets, which we haven't shown until today.
Thank you so much. Thanks for coming out. It's really, really cool to see where this world is going. And you can tell the big boys are interested in it now because they're spending hundreds of millions of dollars to buy these companies. So
that's right.
Thanks, and looking forward to seeing what's coming next.
Good to be here. Thanks.
Be 9 billion people on this planet sooner or later, or at least in our lifetime, for sure. That means there will be 9 billion people getting older and requiring more and more energy and healthcare, attention, and we need to find solutions. We need to find new technologies that help us tackle these challenges that society is facing. Nanotechnology is one of the buzzwords that you keep finding in the news, and in journals such as Nature you find advertisement about new muscles. So carbon nanotubes could be used to create muscles, or they could be used to create ultra strong and lightweight composite materials, even ribbon to the stars. Space elevators is a buzzword as well. Today I want to show you that there is more out there than just flatlands or nanotubes. There are particles, so they're 0D, 1D and 2D nanomaterials. They have all these fascinating properties that we heard about earlier. And we can make them. We see them in the lab. We can go to some applications. We have applications on the market based on some nanomaterials. But there's a lot out there because we can just go through the periodic system of elements and combine them new. How big are these nanomaterials? To give you an idea, you compare a football or a C60 molecule to a football that's roughly the same ratio as the football to the Earth. And with one molecule we can't do anything, we need lots of them. So how do we make lots of them? That's the challenge, because we can't be just staying in the lab. So there are two ways of approaching this. Is a top-down method, which you saw earlier in the talk, and the bottom-up approach, where we also play Lego, but we use molecules or atoms that we assemble in different ways to create either particles or tubes or sheets or combinations thereof. If you think about these methods, one particular method that we're using in our lab is based on chemical vapor deposition. And for chemical vapor deposition, you need basically 3 ingredients. Each one of you in this room could come to my lab, and in an afternoon you would be producing nanomaterials. And the ingredients are heat, a precursor, a carbon precursor, and a metal catalyst. You do a little bit of magic and voila, you end up with a nanomaterial. But the reactor inside is quite chaotic, and what we want to produce is this wonderful perfect material, atomically perfect, and we want to replace some of the carbon atoms with heteroatoms to manipulate the electronic properties. And how are we going to do that? Because if we can't control nanomaterials production, they're pretty useless for applications. I'm hoping to be able to prove you that we actually can make it. There are a couple of pictures here of graphene that contains nitrogen. You see the brighter atom, that's nitrogen, and it has an effect on the local carbon atoms surrounding it. And you can see that in the other picture, the red one, where you see the local density of states is changed just by the presence of this atom. There are various factors that influence the formation, and here you see graphene on copper, which is a standard method. And I'm showing you that the substrate alone also has a strong influence on the graphene domains. You see these different shapes. And what you need for your application is you need a continuous sheet. Now try joining these crazy shapes together. You find a lot of defects. With the help of the ERC, we've been able to patent a device that allows us to monitor what's going on in our chemical vapor deposition reactor and local chemistry to find out what's going on, which molecules form what material, and which molecules are basically wasted. And it helps us to control the structure and to control the composition and the properties of these materials. So for example, we've been able to fill these nanotubes with magnetic materials, and we could show that they're useful for drug delivery, for example, by functionalizing nitrogen-containing magnetic carbon nanotubes that we moved from A to B, for example. Or if you combine conducting materials or semiconducting materials with insulating materials, you could create efficient electronic materials or sensors, or basically the floor is open to you and to your imagination what you could make out of it, provided that you have enough material available. Now there are other materials that we can go down, and that's silicon oxide, for example. You see here these 3-dimensional structures based on silicon dioxide. They could be used as scaffolds for drug testing, for example, reinforcing composites materials, sensors, or you can imagine functionalizing this further. They could be as catalyst materials. And if you're thinking back to 0D, 1D, and 2D, if you reassemble these individual components into a 3-dimensional structure, here we have flatlands of tungsten disulfide put together in a 3-dimensional form to form this flower. That could be a catalyst support or some sort of an emission device. But we need the know-how how to create these nanomaterials by design, and we need the know-how how we can upscale so that we can actually engage with people who are working on the applications. And there are many more applications out there that we are not aware today. But we have the building blocks. We just need to do the next step of taking these building blocks that we're making into society, into the applications. And that leads me to my question is, how can we take customized nanomaterials to solve society's problems? Thank you.
Well, good afternoon, ladies and gentlemen. Thank you very much for joining us here today. Thank you, and welcome to our audience who are viewing this issue briefing on our webcast platform at www.weforum.org. Very excited to be here. This is our first issue briefing in the history of the annual meeting in Davos. They're slightly different to the normal fare you have here. They're not press conferences. They're not announcements as such. It's simply a tool for taking some of the high-class intelligence that we are able to convene upstairs in the Congress Center and bringing some of the cleverest down here to answer questions on topics which we know are of particular pertinence and particular interest. As I mentioned, this is the very first one. It's on the subject which is a perennial favourite on our own forum blog platform, artificial intelligence. I'm going to keep this very free and hopefully informal. I'm going to ask our two speakers, who I will introduce in a second, to give make some brief remarks on the session they've been participating in this morning, and also give us the benefit of their experience in the field of artificial intelligence. And then we'll leave it open for Q&A. So without further ado, I'm very, very pleased to be joined by Alison Gopnik, I do apologize, Professor of Psychology at the University of California in Berkeley. And Ken, thanks very much indeed for joining us. Ken is a professor also from Berkeley, and his specialist area is robotics. Alison, perhaps we could start by giving us a bit of a briefing on your particular entry point into this subject, and perhaps share some thoughts from the session this morning.
So I actually study how children can learn as much as they do. And about 10 or 15 years ago, we started collaborating with computer scientists who were trying to design machines that could learn in the way that children do, partly to figure out about machines, but also to use that as a model for children. And I think one of the things that points that Ken made in his talk is that the interest of AI has been to discover that many things that we thought were going to be very hard have turned out to be pretty easy, and things that we thought were going to be very easy have turned out to be very hard. So, for example, it turns out to be much easier to simulate a grandmaster chess player than it is to simulate a 2-year-old. And what we've realized is this has made us realize just how much even, say, what a 2-year-old learns involves processes that we don't really understand very well and that are very powerful indeed. And I think that was one of the themes that came up in the meeting, is that things like chess or theorem proving, the great ways that nerds prove their machismo have turned out to be not actually so hard, whereas things like picking up a cup or recognizing a face have turned out to be,
or getting to an appointment on time.
Or have turned out to, robots are much better at doing that because they aren't distracted. So I think that was one message, and then another message that Ken emphasized and others emphasized is the question about values. So we know that if we have a goal, we can design a machine with by using a lot of smarts ourselves that can get to that machine, but it can get to that goal. But then when the decision becomes which goals are actually worth getting to, that's something that's a much harder thing to get a machine to do.
Should I
Please do.
follow up on that? Thank you, Alison. So we came to a fair amount of actual agreement that in particular, you've heard so much of the press coverage recently about Stephen Hawking and Elon Musk talking about the singularity. And so one idea I want to propose is that it's time to actually move beyond the singularity. And instead, I propose the multiplicity. Excuse me. The multiplicity is the idea of many people, groups of people, working together with groups of machines to solve problems. So I think this is actually a much more constructive idea because it actually is something we're already doing. In a sense, if you think about Google's search engine, is a multiplicity. The way it works is that every human is using all the human linking structures, human-provided linking structures. It actually is testing humans all the time. When it gives you a list of responses for a search term, it sees what you click on, and it uses it to update so it's smarter the next time. So it's using humans and machines, and that symbiotic combination is something we don't understand enough about yet. So one of the areas of interest at Berkeley and other labs is how do we start really developing a science for this kind of both collective intelligence of humans, but also collective intelligence where humans and machines are interacting with each other. So that we think that, and I don't think the term multiplicity has been put out there yet. And we're hoping if you as a press can circulate it. This is our first announcement of that word. We'll see if it catches on. But I think that idea is it's time to start talking about that instead of singularity. And the other idea we talked about this morning was that there's been a big advance in the field of robotics, which is we've always assumed that robots have to carry all their computing on board. It's just an assumption we never questioned. But it's actually, we're now realizing that it's not the case, that robots will almost always be in a place where they can get access to the cloud. And now we can do processing in the cloud so that very complex statistical computations can be done in the cloud. But then the side benefit is that all that data is available in the cloud so that it can be shared across robots, so that the collective can grow and exchange ideas and information and models between each other. So collectively, they get much better over time. So this idea of cloud robotics is another new development.
So actually, this is a press conference. We have an announcement. Multiplicity is a new
News
word
breaking, yeah.
in the parlance of artificial intelligence. Both, could you perhaps share your personal highlights or key learnings from this morning's session? There were 4 people on the panel, I understand as well, and computer scientists, not just yourself. So, it's a collaborative effort, advancing artificial intelligence. Anything that our colleagues here should be considering writing about?
Well, there's one thing I think we completely agree on, which is that there's certain categories, I would say, that have to do with aesthetics and art, emotion, and design, and one is humor. I don't think we'll ever see a robot telling a great joke in our lifetime. And so there's a lot of limitations or essentially areas where I conceded to the opposition on those points. I think that they're not going to make better jokes than humans. Maybe I'll be wrong. But and then the other thing that surprised me at least was fascinating study of human nature. Everyone voted on which side they agreed on at the beginning and then at the end. And almost no one changed their mind. And despite an hour of us trying to offer new ideas, nobody changed their mind. So this confirmation bias is incredibly alive and well.
Well, I think that's true, but I think also part of the reason for that was, in a way, there was, for a debate, there was more agreement than, in some ways, there was disagreement. Because I think there's pretty general agreement that computers have gotten to be very good at certain kinds of things. So being able to learn from big data sets, for example, those techniques for statistically pulling out statistical patterns from big sets of data, that's been a real advance, and everyone could agree that that's been a real advance. Mm-hmm. Using things like Bayesian probability theory to make inferences, that's been a real advance, and everyone could agree that that was a real advance. The places where, if it's going to be solved, as Stuart Russell said, it'll be 3 or 4 breakthroughs at least down the line, are things like creativity, being able to actually think of a new idea, being able to change the idea you already have, integrating the kinds of things that we humans do with emotion into what AI does. That's something that we don't understand very well. And figuring out how exactly we manage our values, what it means to have a moral system, what it means to have a value system, how it is that we can decide, as people at Davos do, for example, that we need a new value system, that the value system that most people hold isn't working, and we need to persuade people to shift their values. Those are all things that are way out on the horizon, very, very far removed from what our current systems can.
Although I just came from another session, we were talking about manners and digital, this sort of obnoxious behavior of holding your phone on when you're talking with someone. And we were saying that, well, we really can change. I mean, manners and behavior can change. And an example of this is smoking, right? It was just not too long ago when it was very common to just have cigarettes at the table, et cetera. And now, at least in the US, and I think many other countries in Europe, you really can't do that anymore. And we've adapted in a relatively short time. So maybe we need a call for a kind of manners, change of behavior in terms of in terms of technologies. There should be a school of etiquette that we should maybe learn and then start to adopt, so before it's too late.
I think another issue that came up in the meeting that I think is worth pointing out is that in some ways there are sort of two separate questions. One of them is, will we have the super intelligent computers anytime soon? And at least things like being able to revise and change what we think, being able to be creative, to being able to have moral values, I don't think any of those are on the horizon. But I think another thing that came out is there can be lots of damage without having the super intelligent computers. So, natural stupidity will beat out artificial intelligence any time for really screwing things up. We have plenty of natural stupidity, and the combination of natural stupidity and artificial intelligence can be a really dangerous combination. So we do have to think about how we regulate things like autonomous weapons, an example that Stuart gave, or things like a machine that can suddenly change the way the stock market works. And we need to think much more about how to do that. Now, that all is true even with machines that aren't anywhere nearly as intelligent as we are. It is still true that those machines, especially in the hands of occasionally incredibly intelligent but also amazingly stupid humans, especially grown-up humans. It might be better if they were just in the hands of 2-year-olds.
We should have 2-year-olds
still have to worry
at the
about that.
World Economic Forum.
Yeah.
That would be a great session.
Noted. Well, let's work with that. Before I hand over to questions, what was the voting? Give us an idea of what the voting was before and at the end of the session.
Okay. So at the beginning,
We won, by
Yeah.
the way. Let me just point this out.
they
My side
won by a slim margin, but it was about 50-50 about who thought it was that machines
Yeah, it was
would
interesting.
make better decisions than humans, and at the end it was the same. I mean, there was a few points that they had changed. They had beaten us, but
It was interesting that it was 50-50. I wouldn't have predicted
I wouldn't
that
have
to
either. Yeah.
Very interesting. Okay, let's have some questions. Okay, well, can we have a microphone down here? For the benefit of our audience online, could you also give your name, please, and your outlet? The gentleman will take yours, and Michael there in the front row.
Hi, it's Jim Edwards from Business Insider, and I would just want to ask the really dumb question about Elon Musk, who keeps telling people that robots will come to kill us all as soon as they become smart enough. So is he right? Will the robots kill us all as soon as they become smart enough?
No. No, absolutely not.
Elaborate.
First of all, I thank you for being from Business Insider, which ranked UC Berkeley as the #1 school to study robotics. So thank you.
It's not very cozy, isn't it?
But I will say that no, this kind of fear is exactly what the wrong thing. What we need to be doing now is being constructive, not talking about this singularity, because I don't think that's even close. I think the much better, more interesting thing is this multiplicity idea.
Michael Jarlen from Politiken in Denmark. Could you please broaden out the perspectives in this cloud robots you were talking about?
Well, so there's really very quickly, there's 5 advantages to having robots connected to the cloud. The first one is access to data, because you can carry maps, you get access to maps and all kinds of models of objects around you. It's enormous. Second is computation. So when you want to be able to plan a series of motions, that is actually right now with uncertainty as the central problem for robotics, it requires vast amounts of computing. And you can't carry that much computing on board. So you can do that in the cloud. And the third one is the idea that the cloud is actually providing the ability for robots to communicate with each other and share information. So every time a robot is acting in the world, they're doing essentially an experiment. So they report back the outcome of that experiment, and that gets shared and integrated together. The fourth one is the idea that the cloud is facilitating the exchange of humans sharing software. And this is accelerating research in robotics. So there's an open source platform called ROS and something else called Robotics as a Service. That is a new idea, which is basically where you'll be able to very quickly, it's a software architecture that lets you very quickly get access to robot algorithms. And the very last one is that no matter what system you have to program your robot, there will always be cases where things fail or it gets stuck. And then, because your access to the cloud, the robot should identify those situations and then can tap into a human call center. So it sort of reverses what we have now, where we call and we get a robot on the phone. The robot will call and get a human on the phone who will help diagnose the problem and resolve it. So those
the robot will say, "Oh no, not one of those humans again."
Yeah, so I think those things are all, that's opening up all those 5 channels are brand new, and they're really accelerating the field.
Fascinating. Gentleman at the back there, please. And then after that, the gentleman there near the middle.
Hi, Bert Schmidt from Schweiz am Sonntag. I just would like to add to that question before. Do you have an idea or a vision what kind of jobs going to be replaced by robotics or artificial intelligence the next 5 to 10 or even beyond years?
So I do have one answer to that, and I'm going to yield it to Alison in a minute, because in the Swiss expertise, they have scheduled me to be at a panel in 7 minutes. So I have to dash over to there, and I apologize. But I will say this, that I do have an idea about that. I think that there's huge opportunities right now for teaching. That there's a vast need for teachers, not just in classrooms, but for teaching all kinds of things. And that is undertapped right now. So could we find a way economically to allow people to be rewarded for teaching? We feel, and I think most of us have experienced, teaching is incredibly rewarding. So someone out of work, if they have even part-time jobs teaching in some fashion, I think there's enormous potential for that. And so if we can transform the people who are put out of work, which will be inevitable in the short term, but start to use technology to allow them to teach in new ways, I think that could be a really constructive outcome. So is it okay if I depart?
Please do.
All right, I apologize.
Thank you
I'll
very
leave
much
you
indeed
in
for your
excellent
time.
hands, because Alison's terrific. All right,
Okay, so
thank
get
you
your
all.
hard questions ready now. We just have Alison here. Do you have any comments, Alison, on that one point, the jobs and the, I guess the most obvious economic impact?
Yeah, I mean, I think it's fairly clear that jobs that were jobs that were once mechanically done by people in factories are now being done by robots. Some jobs that were done using our minds and brains are going to be increasingly done by artificial intelligence. But I think part of what comes out of the session is that there's enough scope for the things that people are much, much better at than computers, that the optimistic thought is, and those are the things that are the most human ones anyway, being able to do things like have creative new ideas or consider changes in values. If more of us were engaged in doing that, if we could find a business model for creative thought about progress in the future, then that might not be a bad thing. That might not be a bad thing to happen at all.
Okay, if I may, we'll take one more question before we close this. Gentleman here by the middle.
I'm Tetsuya Igarashi from NHK Japan. Nice to meet you. I have like 3 questions, but I'll just take one. Right? And I've been researching about the advancements in technology, and well, in the past 5 years, there's big advancements. What do you think the societal drivers of
Those advancements?
Yeah.
Well, there's a very interesting point which Ken mentioned talking about his multiplicity idea, which is that a lot of the big advances have come because the computers have really been using these millions and millions of examples of these incredibly high-powered computers that have been chained together in a way that they never were before to solve problems, namely all the human beings who are using the internet. So we have these fantastically powerful computers, and they're all working together to put cute cats out on the internet. And then Google can actually use the output of all of those people finding the best cat picture to get an algorithm that actually lets you recognize cat pictures, which is something that every 1-year-old can do with much less data. So some of the advances have come because there's been big improvements in our ability to do things like pick out statistical patterns. But a lot of the advances have come because there's now data available, not only big data in large quantities because of the internet, but also data that's been pre-digested by human beings. So to take another example, machine translation depends on the fact that we have access to millions of human beings who are translating data all the time. And a lot of the advances, the terrible dystopian picture of them in the Matrix of, we're all lying there thinking that we're having fun, but really we're just feeding the machines. That's actually just true. So as we're sitting there putting up Instagrams of our cute cats, what we're also doing is giving data and information to machines in a way that they didn't have it before. So it's an interesting question. Is a computer aided by a million human beings who are who are doing the work without knowing it, a super intelligent computer or not. They're not. It's not super intelligent in the way that a baby is super intelligent, but it can do things that we really couldn't do before. So I think there's quite a lot of reason to believe that having the internet, having computers be able to have access to all of those brains and the output of all of those human brains and use that in their computing has been the thing, or at least one thing, that's made the big difference.
Alison, a final word, if I may. What will be the focus of your work in 2015?
In 2015. Well, what we're interested in, so let me back up for a minute and say, what Alan Turing proved all those years ago was that if we can take any process and describe it in a systematic step-by-step way, then we can program it onto a computer. So when we say computers can't do things, what it means is we don't really understand how they're done yet. So the thing that we're trying to understand is, how is it possible for people to be creative? That's something we just kind of take for granted. But if you think about creativity from a computational perspective, what it really means is there's this infinite, enormous scope of possibilities, possible ideas that we could have, possible skills we could have, possible ways we could organize ourselves into a society. And somehow you have to decide which one of those is going to have the best outcome without knowing it in advance. And somehow human beings, in fact, not just even, but especially 3- and 4-year-olds, can get a sense of, here's a crazy, weird idea, but it's sort of in the ballpark of something that would work. And we don't really know how that's possible for adults, creative adults who are innovative like scientists, or for 2- and 3-year-olds who are pretending, or for computers. So what I'm working on right now is to try and see, can we give some kind of story about how things like play and imagination could actually be implemented in a computational way.
I'll give you what I think happens here. Okay, you are joining the army. They put in front of you a task and tell you, listen, we don't need to replicate it. It must be on time. Think out of the box. No budgets, limitation, just try to build it, okay? And you build it, you think out of the box, you get the solution right, and you move to the next project, right? So if you look at it, we don't have skills of building huge manufacturers, or because we are extremely focused on, having one project, unlimited budget, let's do that. And also it's something with the Israeli culture. If you think something, I know how to do it better.
Yeah. What's your business challenge now for the next 2 years to build this?
I think the biggest challenge will be to hire the right personnel. You can't build this kind of startup unless you have the sharpest minds. So I think that's one point, and the other point is to convince the industry that that's the right solution to take it forward.
So you're probably raising funding. Have you raised any funding for this company?
Yeah, we raised $2.5 million in April from Singularity, which hosts us here, an additional fund in the US, and it will help us to develop the proof of concept of the technology, and hopefully we'll mature it.
Very cool. Well, thank you for giving me a little taste of what's going on here in Tel Aviv. Where do we learn more about it?
You can visit our website at infinityar.com. Everything in there, our Facebook page.
Very cool. Well, thank you so much.
Thanks, it was a pleasure.
So a few weeks ago, Apple bought this little Israeli company called PrimeSense, and a lot of people are like, well, what does PrimeSense make? Well, they make 3D sensors. We saw them at the Consumer Electronics Show last year. But we have a new company that's using their sensor on top of an iPad, and they're going to change the world. And the sensor is called a structure sensor. The company is called Occipital. We're going to see it right now. And who are you?
My name is Jeff.
Factory is a design navigation for unmanned aircraft.
Wow.
Using computer vision. So
he's a smart guy.
Extremely smart. Extremely smart. So I had this idea, and I keep looking for those kind of guys, okay? And I interviewed some of them, okay? And most of them told me, impossible, impossible. And then this guy, I liked his answer the most. He told me, give me a week, okay? And he called me after a week and said, I already drafted the sketch, and how can I do that? And ever since, you know how it is in startup, we're kind of a married guy.
How soon is it going to be before we can buy this and play with it at home?
I think there are a mixture of things that need to be mature. So you need the optics, right? You need the content, and you need our technology. So I think that at the beginning of next year, you will start to see companies working with different technologies to embed them in their glasses. So I guess something at the beginning of 2016, mid 2016, we will start to see those kind of solutions. It's a question whether it will be first for the enterprise industry or for consumer. I think enterprise will adopt it first.
Do you see other places where this technology might be useful, for instance, controlling a dashboard in a car?
Think about a surgeon, okay? Those guys are spending more than 25% of their time in the room looking at data instead of operating. So if you have a very complex operation to do, it might take 6-8 hours. Think about it, 45% of the time is looking through data to understand what to do. Think if the doctor can now have those glasses on top of him, and the entire information will lie over the patient, right? So you can now look at different slices of the MRI and so on. So I think it will go over there.
I've been visiting Tel Aviv all week, and we're here in the Mobley offices. Thank you, Mobley, for letting us do interviews here. What's going on here? Because there's more startups here who are doing this kind of hard science R&D.
Why is it happening here?
Yeah, what's going on here? What's in the water here that makes you different than New York or Berlin or Los Angeles or Seattle, right?
Right. They can build all of this magic.
So the people who are angry at Google for putting a camera on Google Glass with privacy, they're really going to love you because you have two cameras, right?
I think Google took it one step too fast, okay, right? If you look at what we really, when you have new products like that, you don't put it immediately on the street and allow people to do face recognition, right? Let's start with some fun. Let's have two boys sitting at home and playing Monopoly or chess, or even new interactions you cannot imagine. We have a demo in our office that you can play Angry Birds, okay, that we built, but from the point of view of the bird.
Yeah.
Think about it. You are now feeling as if you are flying towards the islands, or it's amazing new experience that you can get.
So I'm still a little confused. Are you going to build glasses, or do you work with an existing company?
We are working with an existing company. Our demo is running currently on Vuzix because they are the one to first provide stereoscopic cameras, but we are now talking to different providers of glasses. When we told them about our ideas, they were immediately, start scratching their heads and said, how come we didn't thought about it, right? It sounds easy. It's not that easy to support all the computation and the right, smart algorithm behind it. But the truth, they much prefer to have additional camera on top of the glasses instead of, a 3D sensor.
Yeah, and a 3D sensor has the Meta space glasses that I saw have a front-facing 3D sensor, but it can only see about 15 feet away from you, right? The 3D sensor throws light, laser light or ultraviolet light, and measures the time it takes to get back and builds a 3D model. Your approach could go much further and can work in bright sunlight, I would assume.
Right, so you got few of the points, which means truly we can work outside because infrared light will not interfere. We can work one against each other, right? Face to face, because we are passive sensors, nothing will interfere. As for the distance, the truth is, as a human, you cannot tell the depth beyond 6 meters. I can replace what everything is behind 6 meters with a poster. You will never know. It's your brain playing with you. So the truth
Which is actually a trick that Hollywood uses all the
Exactly.
time. They paint things behind the actors, and you can't tell because your eye can't see that.
The rule is that you can sense depth 100 times, double the length between your eyes. Okay, so if
100 times.
right, if this is 6 centimeters, you can sense depth up to 6 meters. Now, if you look at the depth sensor, they're trying to generate depth out of every pixel. I couldn't care less. That's what's smart about us. When you look at the table, yes, I want to give you depth for every pixel. When you look at the distance, I don't care. Right? You will not feel it as well. And that's how you can save computation and power, and that's how it should work.
When I went to Meta, they had a team of people developing software to build a new user interface, a new machine computer interface, or a new machine human interface, right? Because we don't have a mouse on the table like we used to have. Now we have our hands in the air, and we have sensors that can tell we're spinning our head and stuff like that. Are you building that new operating system that's going to let us do things with our hands?
Yeah, I think what we currently see in the market is trying to take gestures into the 3D environment. Okay, so you will see actions that will tell you to hold, grab, move, release. I don't do it with my physical things, right? If I want to grab a glass, I will just grab it and take it. So the next generation of gestures, we don't like to call it gesture, we call it hand control.
Hand control.
Right, so that's the way I control stuff. I don't need to teach my little boy how to grab a chess piece, right? I can just take it, grab it. So we are now working on a technology that allows your brain to understand that you catch this piece by lightning and have some signal of voice. But at the end, we need to recognize that you just capture a piece, right? And you want to grab it and move it or leave it. That's the idea.
But that's a lot of computer science, isn't it?
That's a lot of computer science. My CTO, he's a graduated of a project in Israel called Talpiot, which every year they select the 30 most talented guys, put them through university. So this guy did 3 degrees in parallel, math, physics, computer science. It wasn't enough for him, so he did his master and PhD in parallel to working in a military.
All right, we're hearing a lot about wearable computers, particularly ones on the face. You know, we've seen the Google Glass, we've been to Meta to see the space glasses and a variety of other glasses. But the problem is, how do you make this thing cheaper and smaller and more battery efficient? And Infinity Augmented Reality has an answer to that, and we're going to hear about it right now. Who are you?
Hi, my name is Modi Kushner. I'm the CEO of Infinity AR. I started this startup 2 years ago. Prior to that, I was the Chief Marketing Officer of Telmap. We sold the company to Intel about 2 years ago. And what I'm doing is I'm trying to help my boy play more realistic video games. That's what I'm doing here.
Well, that's a good way to be cool, Dad.
Yeah, you know, I was playing, the old startup started 2 years ago. We were playing chess. Okay, and then his friend, classmate, entered the house and said, "Would you like to play Wii?" The boy looked at me, looked at his friend, dropped me and went to play Wii. And I was staring at him and thinking to myself, 30 years ago, I got my first Atari, and I was playing with my friend, staring at the screen, detached from the environment. What's wrong here? Can we do something new? And that was the idea. How can we allow those two boys interact like we did, right, on a board game, but with the excitement of a video game?
Yeah. Now, you're building the engine or the glasses or both?
Okay, so we are building the engine. Okay. We will require some hardware, of course, but unlike all the other solutions that you have today in the market that require huge battery and can last for, I don't know, maybe 15 minutes, we're requiring only 2D stereoscopic cameras. And with that, we can build the 3D environment around you. We know where you are at all time. We allow you to control virtual objects, but more than that, we are the engine that kind of translates the physical world into your virtual world. So if you are an Infinity developer, a Unity developer, you will need Infinity in order to build or to extract the data from the physical world.
Yeah. So you need a pair of glasses that has 2 video cameras, just standard video cameras, right?
Two simple VGA, one color, one black and